What's going on, guys? In this video, I'm going to show you how to make this chain lightning effect. So we already did a video on this in the past. Somebody had asked me to create another video showing how to damage objects and enemies in where like the balls are hitting. So let me just see if I can find some enemies. So basically the way that it works is there's all of these like little balls that spawn when the chain lightning is going. Let me see if I can pause it. So there's like this ball here and there's like balls over there or whatever. Anyway, so basically there's like a radius around each of the balls that will kill enemies or damage objects. And I'm going to show you to do that in this one. Eventually this is going to be a card. So you can see I have like the light card in the bottom left corner. We did a different video on how to make the effect for that. So I'll link that in the description if you want to. Pretty sick. Anyway, yeah, so in this video, I'm going to show you how you can make this effect. Like I said, this is a copy of a previous video. The code in this one's going to be a little bit better, more like the other code was like actually kind of bad. So yeah, if you guys are enjoying the series, make sure you like the video and subscribe to my channel. And yeah. Okay, so to make the lightning, it's really two parts. So there's like a quad that's extending from your character to the point that you clicked. And then there's balls that are getting generated, like these little plasma ball things that are getting generated at each of the intersections that covers up the edge of the plane. So if you right click on the left here, you can just hit 3D object. And actually, it's a quad. It's not a plane, it's a quad. So make sure you make a quad. And it's starting in the wrong position. This is based on whatever you had selected. So just these little dots at the top right, you can click reset and that will move it to the center of the screen. You want to rotate it 90 degrees on the x-axis and then move it up. I think that'll probably be either Z or Y. I don't know, to be honest. No, it's definitely Y. Shit. Okay, so you got this little plane here, and then we're going to put this material onto the plane. And then if we scale it up in the y-axis, you can see it turns into a beam. And this is the beam that's getting drawn between the 2 points. So when you have what you like or whatever, you can just drag, rename it to something like lightning. And then you can drag it at the bottom. So you don't have this material yet, so we need to create the material. So if you right-click at the bottom, you can create a shader graph, URP lit shader graph, and we'll just call this lightning shader tutorial. And if you right click the shader that you just made, you can click create, and then you can click material, and we'll just call this lightning material tutorial because I already have one. And this should default as the shader in the top right. If you right click in the open space, it will just do lit or something like that. So if you don't see lightning up here, make sure you change this drop down and you can just type in lightning or whatever you named it and click on the one that you made it. It has to be the shader, obviously, for it to show. And then you can take this material that you've just made and we'll drag it onto the quad that we've made. And you can see it changed it back into the boring way that it was initially looking. So then we need to change the settings of the shader. So if we double click on this shader tutorial, I'm just going to drag it out here and I'm going to go to the scene view and see if I can get that quad to be in the center of the screen so you can see both at the same time. And so the first thing we're going to do is we're going to add a rectangle. So if you right click and click create node, you can type in a rectangle. And if you click this, basically, it's exactly what you would think. We're just going to change the height of this to like 2, and the width can be like 0.2 or something, right? And then we need to edit the UVs of this rectangle to be what we want. So if we click create node, we can get a UV over here. And then we also need a UV to distort this. So this, if you put the UV into this, it doesn't affect the rectangle at all. So if you put this into here, you can save it and you'll see on the left that it's just a part of this. And basically what we want is it to be distorted along the line. So we're going to mix this UV with a noise texture. Okay, so then this UV actually needs to go into like a linear interpolation or lerp node. There's a node called lerp, and you can put this into the top value of the lerp node. So this will go into A. And then in the bottom part, like I said, we're going to be putting a noise into this. So you can use a simple noise for this. Just change the scale to like 25 or the scale affects it, so you might want to like make a variable out of the scale so you can change it while you're like running the game so that it can be what you want it to be. And then the T node is going to just be a number, and we're going to actually make a float for this because this could change depending on like the scale of your game and stuff like that. So we'll just call this noise threshold. I spelled that right. And then we could just set this to like 0.5, which is halfway right now. So if you drag this to here, you can see that it will mess up the rectangle that we have. And if you save that, you can see this on the thing. This also needs to go into the alpha. So we don't actually have alpha. So on the left, there should be a graph inspector where you can change the settings of your shader graph. If you don't see this on the right, there's a graph inspector button and you can click this to make it appear. Just change this to be transparent. So that way we don't see this black outline. We want it, the dark, like these black parts should be invisible. So you can drag this into the alpha section. And then if you save this, you should only be able to see the lines. Now you can still see this like little gray part to show like where the quad is. We actually want to get rid of that. So we're not going to be casting shadows. We're not going to be receiving shadow. It's lightning, right? You could just change it to unlit probably, but get rid of preserve specular lighting. We're going to turn that off as well. And then if you press save again, it should be transparent in the sections that are we're going to multiply this by a color to make it glow or whatever. But yeah, so this is how we made this. So then this needs to move as well. So we need to have like where this is moving. So if we right click in the open space over here, we can create a tiling and offset node. And this is what will move this. So we can put the output of this into the UV of the simple noise. We want to move the noise. We don't want to move this actual rectangle. The rectangle is going to stay in the same spot, but the noise that distorts the rectangle is going to be moving. So then we can right click over here and create a time node, and we'll put the time node into a multiply node so we can control the speed of it. And then we also want to put a vector 2 because we only want to be moving this on, well, we want to control both the X and the Y of the movement individually. So like X would be like left to right of the movement, and then Y would be up to down. And we're probably going to want to make it negative so it only goes away from the character towards the beam of light. So you can take the multiply and put that into the offset of the tiling and offset node. And then if you change this Y to a 1, you can see that now this is moving. Now this threshold 0.5 is probably way too high. You can see this is like completely crazy. Let's press save and see what it does. Yeah, so you can see that this is pretty nuts. It's, I think, maybe too distorted. I'm not too sure. Let's just change this to like 0.3 or something. I'm not sure. So this is kind of how we made this. And then we need to multiply this by a color. Yeah, so to multiply this by a color, you want to make sure this is a variable. The other ones you should probably make a variable as well. Like this vector 2, you probably want to make a vector 2 variable here. So actually, let's do that. So we'll call this the speed. Like it's kind of like the animation speed, and we'll just put this here, and you could just delete this entire thing and drag this one into this slot here. And then the default value can be actually -2 on the Y. We want this to be going downwards by default. And yeah, so then over here, we need a color. So if you just create another variable, this is the Blackboard, by the way. If you don't see this, just click this Blackboard button at the top. And we could just leave this with the word color, change the mode to HDR because we need to be able to add glow to it. And you may need to make sure that you enable bloom in your game. I'm not going to explain that. If you've been following the rest of the series up to this point, you should already know how to add bloom to your game. But yeah, so like if you drag this output into a multiply node, and we'll put this as B, and then you can put the color into this slot, and then you can drag this into the base color instead. And then we just want to make this like a blue color, or maybe like a whitey blue color, but then just turn the intensity up a little bit. And then if you save this, you should have like a beam that's kind of glowing like this. Yeah, I think this looks pretty good. And then, so the way that it's working, like I said, is this will stretch between the two things. So what you need to do is we can dock this at the top now that we're done making this. And if you're running the game right now, make sure you make a copy of this before you close it. So I'm just going to call this lightning tutorial, or you can call it whatever you want to, and just drag it down here. This is what's called a prefab. So you can use this to copy this onto the screen without having to make it again. So if we delete this, then it's still available and we can drag it back on the screen. So the next thing we need to make is this chain lightning ball. So this is what actually is displaying in between the, oh, that's really laggy, in between the beams. So to make this, this is a visual effect graph. So the first thing you need to do is make sure you turn it on. So if you go to the window menu and you go to the package manager, and make sure this says Unity registry, not in project, because in project we'll only have things that are already imported. You can type in visual, and then one of the options should be visual effect graph. Mine says remove because I've already installed it, but if you've not used this before, it will say install here. This is only valid for projects that are running on the Universal Render Pipeline or HDRP. If you're running a regular Unity project, this won't be an option. So if you click at the bottom here, you can click create, and then visual effects, visual effect graph, and we can call this tutorial ball. And so after you do that, you could just drag this onto the screen. And then if you double click on it, well, you have the scene view enabled. It should zoom in on exactly where it is. So we're just going to move this away from the ground. So let me pin this other one that I've already made up here. And I'm just going to wing this. It's just a circle that like expands and shrinks. It's not really too big of a thing. So let's see if we can move the position up on the y-axis. And yeah, so it's right there in the middle. It's hard to see because it's really small, but we can move this way up, I guess. And we just want to view this in the scene view. So we can put it in dead center of the screen on the left. And then we just want to open this tutorial ball thing, and then we'll do this. So this one is going to be the one that expands and shrinks. So it's going to be the main ball, and then we'll do the sparks after. So the rate really just needs to be like, you got to delete the constant spawn rate. We're just putting a burst of particles that are going to expand and then shrink. So if you press the space bar, you can type in burst, and we'll just do a single burst of maybe like 5 particles. Get rid of the velocity. It doesn't need to move. It's just going to stay in the same spot. The lifetime can be between 0.8 and 1. Yeah, so then here at the bottom, mine has the option for a shader graph. If yours doesn't have this option, which it won't by default, you can go to the edit preferences under visual effects. There's experimental operators and blocks. You have to turn this on. If this is not on, you won't have an option for a shader up here. You don't really need a shader for this. It could just be blue. Like really, it could just be like blue with a high intensity and have it like expand and shrink. So set size over life. Let's hit save and see what we see here. Okay, so let's change this from the default particle. We're going to use a shader graph. So if we right click in the open space at the bottom, we can create a shader graph. It is going to be an unlit. No, it's going to be a lit shader graph, and we'll call this lightning ball tutorial. So if you double click on this lightning ball tutorial, we'll just put this into the same little window thing that we have open for our visual effects, so we can like kind of have them both side by side. So we don't want to cast shadows. We don't want to receive shadows. You have to click this. There's an option for supports VFX graph at the bottom. Turn this on, otherwise it won't show up in the list for you to select it. And then I've drawn this fireball. I'm gonna attach this to the video for free. It's just a bunch of circles that I drew. It's not really anything too crazy. So if you drag this from here, like the image, oh sorry, you also have to make this into a sprite. So if you click on it on the right, there's a texture type. The default texture won't work. You have to change it to a sprite for this to work. So change it to a sprite, click apply, which is in the bottom right behind this window. And then you could drag the fireball into your shader graph. And then you can use this to actually create a gradient so that the different layer, if you don't do this, like if you just plug this in here, all of them will be the same. So let's save this. I'll show you what I mean. And then in this drop down, we can just type in lightning ball tutorial. So like, look, it's got the black edges and it just looks like shit. And so there's a lot of detail in this fireball. And the detail, you can see like the center is like, there's like different layers of it or whatever. But when you run this, there's no separation whatsoever. It's just a blob. So we need to fix that. So let's go back to the lightning ball tutorial. The first thing we're going to do is we're going to change this from opaque to transparent. And you can drag the alpha from this into the alpha here. And then the alpha from this can also go into a gradient. Yeah. And then the gradient here is where you can actually change this. So right now it defaults to white, but if you make the middle blue, you can see that it actually appears. And then you could go one further. And if you change this to like white, you can make the middle of it brighter. So just maybe make this a little bit bluer. And then the space between here is how far in the center of this it will be. So like you can see that in the preview on the left. So we want this to be about here, and then you can turn this up a little bit more. And you can play with this as much as you want to. I think I've done tutorials on this before. So you can see the preserve specular lighting there. So when this is running, that box that's around it, that's the specular lighting. We're going to turn that off, and that should get rid of that background. So you can see that this is like a little fireball. We also want this to be spinning. So in the update particle, let's go back to the tutorial ball visual effect. And if we press spacebar here, we can add angle. So this will make it so that this rotates over the lifetime. We only want to rotate the Z axis because it's a picture and it's facing the camera. So you can see that down here, orient face camera plane. So this little quad is facing the camera. So we only want to rotate it. If you rotate it on these, the square parts of it will be moving. If that makes any sense. So let's just make it something like 1 for now. So you can see it kind of rotating, and we want this to actually be super fast because it's the lightning, right? So like it's like shimmering or whatever. And we want this to be way brighter. So the middle of this can go up to like 10. And then let's save that and see. Yeah, we want the lifetime to be less than that. So the lifetime can be 0.5 to 0.8 maybe. And we also want to set the size. So at the bottom here, in this set size over life, if you click on this in the inspector on the right, you can see that the composition is overwrite. So we need to change this to multiply. So if you change the size, it won't be limited. Overwrite means it's going to be whatever this size is, and everything else is going to be ignored. So we want to set that to multiply. And then up here in the set lifetime, if you press spacebar, you can hit set size, set size. And you can make this random if you want. Let's just start with 1 and see what that looks like. So we probably want this to be like 3. Okay, so that's really cool. We just want to dial down the intensity a little bit. It doesn't need to be 10, maybe 6.9. Okay, and maybe the rest of it should be a little bit more bright, and then that can be a little bit less bright. So let's turn up the intensity of like the far edges to like 1. And then this could also have a little bit of intensity too. So we want more of the outlines of those little circles to be visible. We do want the center to be a little bit brighter than the rest of it though. So this should go to like 4 maybe. I don't know. We just don't want it to be overpoweringly bright because also the beams of light are going to be bright too. So let's just try this. Let's just change this to additive for a second and see if that's any good. Yeah, so that's a little bit brighter. Let's just turn this down. So additive makes it so that because we put 5 particles, they all add together because they're on top of each other. See, that's looking way cooler. Okay, so you can mess around with that as much as you want to. I'm not going to spend all day on that because I already have one that I like. It's actually not the one that I showed you in the demo at the beginning. It's the one from my initial game, and I made a video on how to make that one, and you can get the exact settings from the other video. Okay, so then for the sparks, if we just right click in the open space over here, we can click create node, and we'll click system, and we just want a simple particle system. We still want this to be a burst though, so we're just going to drag this up so they're kind of in line. And instead of a constant spawn rate, we can delete that, and we'll just press spacebar and type in burst. And we'll just make this 50 particles. There should be a lot more of these than the other one. And if you make it 50, you also have to put the capacity to 50 because this is only going to burst 1 time. You don't have to make it higher than that. And the velocity, we want this to be only going upwards in the y-axis, but the x and the z can be between -50 and 50, maybe more than that. We want this to go pretty far and pretty fast. So we'll just do like this. and this can be 0. Some of them could just stop right when they spawn. I think we'll leave it 1 to 3 and see how that looks. We're not going to add a shader graph to this one, but we are going to set it to additive, and you can already see the particles. So we want to change the default particle to this white one. And then the size over life should be the opposite. So it starts at the max size and then it goes downwards. So we want this to go like this. And then we can hit save. And so this is way too large. So each of these needs to have a size and then be multiplied. So click on set size over life and change it to multiply size over life. This is the same thing we did in the other one. And then up here where it says set velocity, if you press spacebar, we'll set the size and that. And then we'll see. So those are pretty small. Okay. And I think this is still a little bit too small. So we're just going to change the size to a random for these. So we'll turn this on to per component using the inspectors. When you click on set size random, again, you get options to change it up here on the right. And so we'll set this between 1 and 2. And let's see what that looks like. So these are really big, but I think the problem is that this is really close to the camera. So we have this way above the spawn spot and we just need to move it down. So let's minimize all this stuff and we'll just change this to like 5 on the y-axis and we'll change it to 0 on the x. And let's go to the game view so we can actually see what it's going to look like. And so these are way too big. So maybe this should actually be like 0.5 to 1 at the max. And the size or the lifetime needs to be way less. So maybe like 0.2 to 0.7. We don't want them to live longer than the ball, really. So that's looking okay. And then we want these to be kind of blue. So we can get rid of all of these keys at the top, make it the max alpha at the start and then 0 at the end. And then this color should be really like a blue with like pretty high intensity because they're supposed to be sparks, right? So this should even be higher intensity than that, maybe 9.8. So that's kind of cool. This ball that's in the middle is way too small. So we need to make this way bigger. So let's do 7. And these are too big. So let's just go back to where we were, 0.1 to 0.3 maybe. It's looking better. And again, this ball is still too small. So let's do 12. Okay. And if you change the orientation to a long velocity and you add a scale, so this is not the same thing as the size because the scale is you can control the X, the Y, and the Z, and you set the Y to maybe like a random. So let's change the random to on per component, and the Y can be between 1 and 5. This gives like longer sparks, which makes them a little bit more realistic. Let's see what 15 looks like. So what we want to do now is we want to drag these two things that I've just made. Let me just tutorial ball. This is the one I have. Yeah, let's drag this down here. So we've got the lightning tutorial and the tutorial ball. And so we'll go on to our main character. And you're only going to have this, obviously, if you have been following the series. But if you haven't been following the series, you're not going to have this. So you can see where I've made these 2 spots for this. So at the very top of my player attack code, or this could be a new script, if you're just following this and you're not following my tutorial series, you just need to create 2 variables at the top. One is the chain lightning attack and one is the chain lightning ball. And if you're like been using Unity for a while, this is pretty much the same thing you do with like everything. So we'll take the tutorial ball and we'll put it into the chain lightning ball slot, and we'll take the lightning tutorial and we'll drag that into the chain lightning attack slot. And now let's run the game, and I want to take a look at what it looks like now. That looks pretty sweet. Okay, so something I missed in the lightning tutorial ball is this multiply size over life. This is actually supposed to be going bigger and then smaller. So like it starts out very low and then there should be a key in the middle, and this should go way, way, way up. So maybe even to like double or triple the size. And then it goes back down. So let's just rotate this so that it's flat like this. And then let's hit save and we'll go back to the game. So now it's way too big, but that's okay. We just need to change the so let's drag this again. Let's just drag this away from the thing. And then we can do this and we'll right click. So these balls are way too big. Yeah, so let's set this to like 3, or it could even be like random so they're not all the same size. And then let's actually change this to like 5. It's too much. Yeah, that looks a lot better. And it looks like the thickness of this lightning beam is maybe a little bit too small. Like I said earlier, I'm not going to spend too much time on this, but to change the thickness, you could change the width, or you could change in this material. Sorry, this is the wrong material. This one, you could change the noise threshold, you could change the speed, or inside of the shader itself, you could make the width bigger to make it a little bit thicker if you want to. So you could make it 3 or you can make it 4. This will make the beam a little bit fatter. If you make the beam too fat, you'll lose all of the detail. The faster it's going in the Y, the less, like it will show it going faster, but it'll be harder to see. Let me just change this to like 5. I don't know. Anyway, let's just go over the code. You can make it thicker or thinner and play with the settings on yours and just make it whatever you want. So this is the player attack code. We already made this in a previous video. We've actually been working on this for the entire series, but I'm going to highlight the part that actually does this. So if you want to make a separate script where you're not using my game, you'll be able to do this. So the first thing is inside of the update method. If we get input.get button fire 3 is right clicking for us. This could be different for you. So if you go to your edit menu and you go to project settings, or there's a tab for input manager. And there's a bunch of different things under this list. So fire 3 is what we've set here. And for me, that's mouse 1, which is the right click button. But maybe for you, it's a different button. The reason that you use the input manager is if you're using like a controller. This is the wrong one. Hang on. Oh no, it's the right one. Okay. The reason you do this is like if you're using like a controller or some other thing, you can there's different buttons that would accomplish this fire 3. So we're using when we our button is mouse 1 for this, which is right click or left shift. And that does fire 3. You could create more of these as well. And so when fire 3 happens, we change the player state to attacking. If you're using your own game, you're not going to have a player dot state, so you can just skip that part. If you don't do something to limit how often they can attack, when you right click, this might happen a bunch of times all at once. So yeah, you can figure out how to do that using the player state. Again, you can watch all of the series leading up to here, and you can figure out how to do that using the series. So we're going to start a coroutine to do the chain lightning. So inside of the coroutine, we're setting the player card to null. That's for a previous for a video that's going to be coming in the future. Like I said, this is going to be a card. You're not going to be able to just use chain lightning and kill all the enemies in all the rooms without doing anything, right? So this is only going to be if you have that card. I'm using my animator to play the light card spell. So this is my character swinging his staff. If you're using my game, this will make sense. If you're not, you should just put your animation here. So that's not connected to the actual chain lightning happening. So after 0.3 seconds, this is just giving time for my character to actually swing his staff or whatever, so that it looks like it's coming out of it. So if you see how like he changes his stance to actually have the staff facing forward. So again, if you're not using my character, then you could do your own animation or whatever there. Then we're getting the start location, which is the attack spawn spot. So on my character, I have a circle in front of where my staff is, where I want the attack to appear. So you can see it. It's right here. So that's where it actually comes out of. So you can move around where that starts from. You could just use your character as this if you want. Like if you're using a different game, you could just put your own character there. But I've dragged that attack spawn spot into my game. Like at the top here, I have an attack spawn spot, which is the transform of that ball. And that's where the chain lightning is going to start. Then I'm playing the thunder noise. Again, this is something that I went on pixabay.com. I downloaded a clip of thunder for free. And you just want to make sure it's one of the ones that doesn't require that you pay something. Like there's a lot of them that actually like require like you to pay money, but this is creating a plane. This is not the same as like an object plane. This is an invisible plane that goes on forever. Okay, so we're creating a player plane that has that's facing up towards the camera, and it's created around the character's position. So like wherever the character is, that's where it's generating from. It doesn't really matter, but just think of this as like an imaginary plane that goes on forever in all directions. So we're creating a plane, and then we're creating a ray that's going to use the mouse's position to cast to get a point on that plane that we just made. And then we're creating a float for the hit dist. So then we are setting the target point to the start location, which is where our spawn spot is. So where that little sphere was, that's going to be the target point. So that's the starting location of the lightning. So we're basically taking a plane from where our character is, where the attack spawn spot is, and we're stretching it to wherever we clicked on the screen. So this is where we're actually casting this ray that we made. So this is not casted yet. So we're casting the ray at the player plane, and wherever it hits, that's where the next target point is going to be. So I guess we don't really need to set target point could be null here because we're always going to get a position. But if it doesn't get a position, it will be the start location. Then for 0 to the number of chain lightning instances that you want to spawn, so you can change this number to change how many times it will proc on the screen. Don't make it too high. I'll probably crash your computer. We're going to destroy this while we're instantiating it. So we're instantiating that chain lightning ball that we've been making. So that's like the cylinder ball or whatever. Not cylinder. It's a spherical ball that we created, the effect. We're going to make that at the start location. We're going to make it 5 above it. So it's like above the ground. So that's higher up so that it doesn't clip into the ground, because depending on how big the ball goes, it might be too low and it might hit the ground. We don't want that. The rotation of it doesn't matter. It's a ball. It's the same on all sides. And then we are killing it after 2 seconds. So after 2 seconds, this chain lightning ball is going to get destroyed. We're wrapping this in destroy because if you don't, it will stay in your inspector forever. And as you keep using the spell, it will accumulate more game objects and then it will lag. So this is the part where the guy was asking about in the other video. So we're using an overlap sphere. So physics is a built-in class library that comes with Unity, and we're using an overlap sphere to check if there's anything in a cylinder around the ball. And because this ball will get generated for each point on the thing, it will check every single point. And this is the radius at the very end. So we've got the start location, which is where the ball is appearing. And then we're checking 15 around the ball. So if you want to make this larger, you could make it just a bigger number or whatever. So then for each of the colliders in the hit enemy, we do our damage code. This code is copy pasted directly out of the spell script that we use to damage enemies normally. We're doing 15 damage, which is going to kill pretty much all the enemies except for maybe the boss. The boss has more health than that, but I'm not going to show you the code inside of here. This is part of my game. So if you're using your own game, I'm outputting a unit, which is specific to my project. We went over this in great detail previously. So you would want to, inside of here, for every collider that you hit, you would want to check your collider for a script. And so instead of a unit, you would have the name of your script here. So it could be enemy health or something like that. And then if you get the component, then you will damage your enemy however you've been damaging your enemies. Or if there's a barrel or some other object that's inside of this, you can actually make it get hit by this. So you would put the script to actually make the barrel blow up or do whatever you want it to do inside of this. Then we're getting the distance between the target point and the start location. So the distance between where we clicked and where our character is, but the start location is getting changed. So like every time this iterates, where it ended, like the last point will become the start location at the end. The direction will be the target point minus the start location normalized. This is a very common thing. And then the rotation will be the look rotation towards that direction Multiply by 90 because we're using a quad. So remember at the beginning, I had to rotate the quad 90 on the x-axis to make it face the camera. So we want this to be facing the camera. So we're going to multiply by 90. If you don't do this, it will be facing sideways and you won't be able to see it. And then we're going to instantiate the chain lightning attack, which is the quad that we made earlier. And it's going to go from the start location. But if you put it halfway between the start location and the target point, because of the way it works. Oh, this is my player here, and we want to draw. Let's say we clicked here, and this is where the chain lightning is going, and we're spawning it here, but we don't want it to go like this. We want it to go like this. So because of the way that it works, if you spawn it here and it's facing this way, then it will go double this the length, like it will go halfway between this. So what we want to do is we want to take the target point minus the start location divided by 2 to move it back to the start spot where it actually is, because when you instantiate it, you're instantiating it dead center, like it will be it will go over anyway. So you have to do this, and then we're adding 5 so that it's above the ground, the same thing we did with the ball, so they match. And then the rotation is the rotation from here. And then we're gonna the scale of it is the distance between the 2 points. So that's what we calculated earlier. That's going to be the size of the thing, and the X and the Z can stay the same. Then we're going to destroy this after 0.5 seconds. So it will only stay there for half a second and then we'll get deleted. Then we're going to wait 0.5 seconds. We're going to get a new target so that the next proc of the chain lightning doesn't actually happen instantly. It happens after a certain period of time. You could turn this up. That actually might be cool if you change this number and make it a little bit longer so that each ball comes out like slower, or it could be random. You could put a random number here between like 0.1 and 0.5 or something. And it could like stagger how it goes and we'll make it feel more like random. And then we're picking a new point that we want this to like we're getting a random new point only on the X and the Z axis. So if you turn these numbers up, the possibility of how far the chain lightning will extend will become more. So the distance between the 2 points. So let's say we're here and we shoot a chain lightning here. The next one can be within a 50-50 radius. So 50x, 50y radius. It's a X and Z, but it doesn't matter. So it can be within a 50 radius that it appears. So if you want, you could make this bigger and it could make it go further. I don't think that's necessary because actually, if anything, it should be smaller because a lot of the chain lightnings are going outside of the screen. So you can kind of see that here. One other thing that I forgot to do. So in your tutorial ball on the right, you can see the culling flags is set to recompute bounds and simulate. Change this to always recompute bounds and simulate. And also in the lightning shader tutorial, you want to change the depth, the depth test to always, because we always want this to appear over top of everything because chain lightning will be like at the front of the screen. And same with the chain lightning ball. So inside of this, you want this to also be always, and then you always want to recompute bounds and simulate for both of these. You can only do it for the ball because it's the visual effect graph. The other one doesn't have that option. So now if we run this and it goes over the edge, you'll always be able to see like the ball and the line, and you can see it through everything. So that makes it look a little bit better, I think, in my opinion. Yeah, so let's go back to the code. So then the start location becomes the target point. So the second beam, this will become the start location. So then it does the same thing to another point from the start location. And the target point is obviously going to be the random that we just generated. So then this will happen 4 times. And then we're going to destroy the initial chain lightning ball that we created. And then we're going to return after 0.6 seconds. And then we're going to set the state back to idle and play the idle animation. So the way that it's working in my game is that if you are in a state other than idle, you can't do this attack. So I'm checking if the player state is idle. Player is a static class. If you haven't been following this tutorial series, you don't really need to worry about that. You could just put a timer or some type of like Boolean check or whatever. But yeah, so I mean, that's pretty much the entire code for this. Okay, and this is actually the last thing that I forgot. So the size of your actual quad that you're using actually matters. So if the scale doesn't look right, you can change this X number to be bigger or smaller. So like changing this affects how thick that lightning is. So if you want to change the width, it's actually better to change it with this number rather than changing the width in the actual shader. So if you go back to your shader, you can find the width and just set it back to 0.2. That's what it should be, and then save it, and then go back here. And if you do that, it should look a little bit better. And then back here in the tutorial material, you can change this back to like maybe -2. I don't know. So it just looks a little bit more lightningy, and then like as well, maybe just do that. So it just makes it look a little bit better. And then the other thing you could do is inside of this is after a while of messing with this off camera. So the lightning ball, put another key right here. So that way, because the difference between these two was too far away. So just put another key here. Make sure this one's a little bit less intensity and this one is a little bit more. And then after you're done that, back in the lightning ball, you can change the oh, sorry, this is the wrong one. The tutorial ball. You can change it. Actually, back here, just change it to alpha. Or sorry, yeah, alpha. Rather, we change it to additive, but additive is actually not the better one. So when you change it like that, the circle actually just looks a little bit cooler, and the lightning actually looks a little bit better. So I'm going to save it like this, and I'm going to export this, and you can download this entire project from my Dropbox for free. It's going to be linked in the description of the video. I hope you guys enjoyed the video. If you did, make sure you like the video and subscribe to my channel. And yeah.